Hey everyone, welcome to this video, and today we are going to build our own NotebookLM clone. And yes, this is going to be a hands-on deep dive with code. The reason for me to do this is not to reinvent the wheel, but to understand how one of the most powerful tools for research and learning actually works under the hood. So by end of this video, you'll learn how you can extract multimodal data, including text, audio, video, along with YouTube videos and website URL into an LLM ready format. Once that is done, we are going to use an embedding model and store all of this knowledge inside an open source self-hosted vector database. And on top of it, we are also going to add a memory layer so that it can remember all the conversation and user preferences to give you an even more personalized experience. And finally, once all of this is done, you can either chat with it or generate a podcast from this knowledge using a fully open source, locally running text-to-speech model, which is also one of my favorite parts. So before we jump into the code, let me show you a quick demo of what this thing can do. So currently what you're looking on your screen is a Streamlit interface that we have created for our NotebookLM. And we are going to do some research on context engineering today. So to do this, I'm going to add a paper on context engineering from Stanford. And then we are going to use this blog post from Anthropic AI on the same topic. And the third thing that I'm going to, add to my knowledge base is this video from LangChain, again on context engineering for agents, right? So let's add them one by one to our knowledge base. So in here, as you can see, you can just drag and drop any audio, video, or text file. So let's say I want to add this paper here, right? So first I'm going to add this paper. Click on process file. It is going to process this file. So the first piece is already added and it's part of my knowledge base now. And now the second thing that I'm going to add is this blog post from Anthropic. So you can add any number of website URLs that you want here. So let's click on process URLs. Perfect. So now this is also part of our knowledge base. And the third thing that I want to be part of it is the YouTube video. So you can just go to this tab YouTube and paste the URL for the video that you have. Okay, so we have successfully processed the YouTube video as well. Now all the three things are part of our knowledge base and it's ready to interact with or create a podcast on top of it. So first, let me show you how the podcast studio thing would work. So in this case, like you just need to, select which knowledge source you want to use. So let's say we want to create a podcast on top of the Anthropic's blog on context engineering. So I'll just select that. And you can choose the podcast style, whether you want it to be conversational, an interview, a debate, or educational. So let's say we'll keep it conversational. And the duration can be also kept under 5 minutes. So let's do that. This text-to-speech model is running 100% locally on my machine. I'll tell you more about it once we deep dive into the code and everything. So our podcast is ready and it is about 2 minutes and 34 seconds.
Welcome everyone to our podcast. Today, we're diving into the fascinating world of context engineering for AI agents, as discussed in a recent document by Anthropic.
Thanks for joining us. It's such an interesting topic. So context engineering is becoming a hot topic, right? It shifts the focus from just prompt engineering.
So if you notice, we have two different speakers. One is a female voice and the another one is a male voice, and they are basically having a conversation with each other and explaining context engineering to us. Okay, so I hope you liked it, and I'm going to explain all of this once we do a deep dive into the code and how this is built. But in interest of time, let's move to the next feature and see what else we can do with it. So we have seen the podcast studio. Now we can go to the chat interface part, and in here we can ask any question that we want to ask about all the sources that we have added to our knowledge base. So let's do that. Okay, so the first question that I'm asking is what is context engineering and how it's different from prompt engineering. So let's see how our system answers this. Alright, so we have an explanation for this, like how context engineering works and how it's different from prompt engineering. Now, I also want you to notice that our system is not only giving us answer, but it is also generating us citations for it, right? So in this case, it tells us like from where this answer is generated. So if you look at this, once I hover over the first citation, it says that, it is referring to the Anthropic's blog post. And since we explicitly asked about, difference from prompt engineering, I think if you go here, this blog post explicitly talks about the differences between prompt engineering, context engineering. So which is great. So now that we know that it can generate citations, so we know that our system is not hallucinating. All right. So now that you've seen how it works, it's time to understand how you can build this yourself. So I'm going to start with giving you an overview of the entire project structure, because there are a lot of code files and all. So there are mainly two things. One is an app.py, which is basically the Streamlit application code that we just saw. And then I have also created a demo.ipynb, right? So this notebook would help you navigate through the entire functionality, and it will help you understand like how you can go through or how you can adapt it to your own use case. I'll be going through this notebook and each cell of it step by step. So we'll do that in a moment. So we have kept the entire code modular so that you can easily modify it, understand it, and adapt it to your use case. So we have modules for document processing, audio processing, web scraping, generating embeddings, and then storing them inside a vector database. So all these scripts and all these modules are separate, and you can easily adapt or modify them according to your use case as well. And finally, once all of this is done, we have a generation module where we have put the entire code for RAG, so that once you have all of this knowledge that you extract from different sources stored inside a vector database, how you can do RAG over it. And then we have a module for memory. So in here, we are going to use JEP, and it's 100% open source. You can self-host it. And this is where we are going to, add all the code for storing all the conversation, storing the user preference, so that it gives you a much more personalized experience. And finally, we have a module wherein we have written all the code for the podcast generation part. So we have a script generator, and we have a text-to-speech.py, wherein once the script is generated, we are going to take that and generate the entire podcast out of it. So now that you have an overview of how the project is structured, let's move to cursor and go through the demo notebook step by step. All right. So now I'm going to go through this notebook, and we are going to understand like how the different components that we just saw are going to work together. And it will also help you to understand and adapt this code to your own use cases, right? So first we are going to do all the necessary imports. And the very first thing that we have is how to process the documents. So we are going to import all the necessary elements from the modules that we have created. So in this case, we need a document processor and a document chunk, and I'm just adding some sample data. So basically there's a data folder where we have all the different modalities, like we have an audio file, we have text file, and this PDF file. So we are going to process it, and right. So it is able to extract out all the text, convert it in form of chunks. And if you see, like each chunk has some metadata, or we are calling it citation information. And this is something that we are going to use to produce citations for everything that our LLM is going to generate. This is something that you've already seen in the Streamlit demo as well. So the next part is processing the audio files. So again, we are going to use this harvard.wav file. And in order to process these audio files, we are going to use assembly.ai, since they provide hundreds of hours of free transcription, and the quality is also state of the art. But since the entire code is modular and all, so feel free to, use any other tool that you want. That's fairly easy to do it. But in this case, we are using assembly.ai. So let's do that. So in here, the transcriber is going to, process this audio file and extract out all the text. And once everything is in the form of text, we can again, do the same thing that we do with docs. We can chunk them, embed them, and store it inside a vector database. And if you want to, add YouTube video as part of your knowledge base, which is something we also did by taking the LangChain's video, you can do that as well, right? So under the hood, we are using YTDLP to download the YouTube audio, and then again assembly.ai to transcribe it and get everything in form of text. And since assembly.ai also supports speaker diarization, so if there are multiple speakers talking in the video, we can easily do that as well. So let's run that. Okay, so we have processed the YouTube video. So I quickly wanted to show you some code here. So this is about the document processing part. So we have created a data class called document chunk. So once everything is in form of text, we are going to reuse this again and again, and it would store the raw content of the document, the source file, whether it is coming from a text file, audio file, or a YouTube video, it is going to store that, and the page number and rest of the relevant information that is important as part of the metadata. And this is something that we are also going to use for generating the citations, right? So it also has a function called generate citations, and I think we have already talked about citation and like how they are helpful. So this is the code that is taking care of that under the hood, and it's modular and it can be again and again used for different data sources as well. So moving back to our notebook, we have covered till processing a YouTube video. So the next part is web scraping. Since we also added a blog post from Anthropic as part of our knowledge base during the demo, so you can bring in any website URL, and we are going to use Firecrawl, which is again open source and had state-of-the-art web scraping capabilities. And the next thing that we are going to do is to take all the chunks that were generated so far from the document, from the video or the audio, and put them together, and then we are going to use this ByBZ, which is an embedding model that we are using from Hugging Face. You feel free to use anything else that you want. It's fairly easy to modify the code as well. So let's do that. Okay, so now we have generated all the embeddings. The next part would be to store all these embeddings inside a vector database. So this is where we come to the part where we set up and initialize a vector database, and in this case we are using Milvus, which is 100% open source. It is built for scale. You can also run it inside a Docker and deploy it anywhere. The code to do this is also fairly simple. They have a Python SDK, which is what I'm using here. So the first thing that we are going to do is to initialize a vector database. You specify the path wherein you're going to store all of this information, and you also provide the name of the collection that is going to be created. So we are calling it as NotebookLM collection, and then we create a vector database and insert all the embedded chunks inside it. And in here I have also put a sample query, right? So we will take up this query, we'll again convert it into a vector embedding, and then do similarity search and fetch some relevant context. So to quickly demonstrate this, it is providing you the relevant chunks based on the query that we just did here, right? So this is something that can be used by your RAG setup as context. So next thing that we are going to do is to add a memory layer, and this is something that will help us to remember all the conversation and the user preferences so that it can give the user a more personalized experience. So to add this memory layer, we are using Zep AI, which is again 100% open source, and they provide a knowledge graph based memory that can be updated in real time, and so that it helps your agents adapt and learn as they see new data as well. We'll quickly see like how the memory part would come into play, but first, let's set up the RAG part. Now that we have the vector database ready, and what we are going to do is to do a simple RAG setup. We are going to take a query, we'll fetch the relevant context, feed it to an LLM along with the query, and generate a final response. So let's say the query is, since we used the raft paper as context, and the query is like what is raft and how it differs from RAG and fine tuning. So let's do that. Okay, so we have the response here, and it tells us like how raft is different from RAG and fine tuning. Along with that, if you can see, it is also providing us all the different sources, like the different sources that have been used to answer this question. Although we added data from YouTube, websites and all, but since this question is specific to this particular document, it is only fetching the relevant chunks from it only, right? So these are something that we can use for the citations. Coming to the next part, since we just had our first conversation, we want to store this conversation history inside our memory. In this case, like a conversation turn would look something like a user message, an assistant response, the source that is being used, the timestamp, and the session metadata. So all of this information can be stored inside our memory layer that we have just created using Zep. So let's do that. And the code to do that is also fairly simple. Since we already created a memory object using Zep, just to recall, I'll show it to you here. So this is our memory or the initialized memory object that we have here. We are going to use the same object and store this conversation history or the RAG result that we just got from our previous output. This is the RAG result that we got. So this would have everything or the conversation history that we just saw, and it is going to be stored in the memory. We'll say that wait for indexing so that it is properly ingested inside the memory so that we can again tap into the same information if required. So I'm just running it, and the conversation context is here, and we will be able to use this in future as well. So to quickly demonstrate this, let's say the user asks a follow-up query, or maybe, again ask like, what did I previously queried about? We are going to use the context that we generated from the memory as part of the new context that is going to go to the LLM. And this is where, memory is going to come into play. And again, as part of context engineering also, it's very important to have a memory layer so that it can understand or it can have the context about the user preferences or all the conversation that have previously happened. So this is exactly what we are doing. And as you can see, like it says that we just discussed about RAFT, which stands for Adapting Language Model to Domain Specific RAG. So which is pretty great. I mean, it is able to now remember our previous conversation as well. Last but not the least is the podcast generation part, which is again one of my favorite part. So what we do in the podcast generation part is we first take the raw context that is in form of text and then convert it into a podcast ready script, right? So just to show you some of the code for it, let me quickly go to the script generator part. We are basically doing a bunch of prompt engineering here. So if you remember, like when we were doing this podcast, the user can easily select the conversation style and all, and the duration, like for how many minutes this conversation should go on. So all of this is being taken care in here. So we have the style prompt, whether it should be conversational, educational, interview, or debate, right? And along with that, we have provided some instruction like what it is meant by each of these styles. And then we can also provide the duration guideline, like whether it should be 5 minutes, 10 minutes, or 20 minutes. And finally, we have another prompt that takes in those guidelines and defines some conversation rules, right? So the rules can be like each speaker should speak 2 to 4 sentences before alternating or switching to the next user. The conversation should flow naturally with smooth transitions and all. So all of this instruction would help us to, create a really nice and a natural script for the podcast that is going to be generated. And this all starts with the raw context that we fetch from the different sources that we have. So coming to the next part, which is the text to speech generation. So we are going to use Kokoro, which is a really great open source model. It is extremely small and produces real high quality audio, and you can even run it on a CPU machine, which is exactly what I'm doing today as well. So moving back to the notebook, let's go through the first part, which is basically transforming your document into an engaging script for the podcast. So this is what we are doing here, and we are again using all the code from the 2 modules that we just saw. Okay, so we have the script generated. As you can see, like we have the different speaker, the speaker 1, 2, speaker 1 is speaking again, then speaker 2, since we are basically trying to alternate between 2 speakers who are having the podcast. Once the script is generated, and again we have saved it to this outputs folder, we have all the speaker labels and everything that we needed. And once this is done, we are going to run the Kokoro text to speech model and generate a high quality podcast wherein we have different speaker and each of them sounding in a natural way. So let's just run that. So we have like the different segments generated here. So if we listen to like one of them here.
Welcome everyone to our podcast. Today we're diving into some fascinating insights from a recent document on a topic that's really making waves in the AI community.
And to make the user experience really easy, we wrapped it inside a Streamlit application so that it's fairly easy for the user to use all this functionality from a single interface and do some sort of research and learning on whatever topic that they want. And they can grab this information from different type of data sources, be it audio, video, website URLs, YouTube videos, whatever they want. With that, we've come to the end of this video. I hope you enjoyed this demo, and thank you so much for sticking around till the end. And let me know in the comments what you liked about it and what other topics you would like me to cover. Thank you so much. I'll see you next time. Bye-bye.